Erin from Silver River Museum.
I'm Ethan at Ward Highlands Elementary School.
Ethan, did you know that there are some animals that hunt by the light of the moon? Yeah, there are, right here in Florida. The moonlight makes a difference. Tonight's a new moon, so it's going to be pretty dark. That might make it difficult to hunt, but I'm not sure. In fact, the animal that likes to hunt by the light of the moon is a lion. Did you know there's lions here?
Yeah.
It's not a regular lion, is it?
Mm-mm.
What kind of lion is it?
It's a little insect that digs these upside down volcanoes, and then when ants crawl, they fall in, and then the antlions eat them. Speaking of it, I see some digging up dirt.
Ooh, so they're called antlions,
Yeah.
huh? And antlions are insects that go through complete metamorphosis.
It's kind of like a caterpillar, and then a cocoon, and then it turns into a butterfly.
Right. For the antlion is its larval stage after the egg, and it can stay an antlion for up to 3 years. And after it goes through its pupa phase, it becomes an adult, and it looks a lot like a dragonfly. But most of its life is spent right here in the sand hunting for ants. So we want to do an experiment and find out how the size of an antlion pit is affected by the amount of light, especially moonlight. But if we were to set up the experiment outside, there's probably a lot of variables that could mess up our results, right?
One, my sister.
Definitely. What else do you think could mess up our results?
Our cat.
Maybe our cat who likes to come out here. So when you're dealing with things like insects and you want to learn more about their behavior, sometimes it's better to set up a controlled experiment in the lab. In order to do that, we have to collect some antlions,
Okay.
don't we? Okay, here's your container. All right, so tell us what we're going to do. How are we going to catch an antlion?
You scoop it in, and then you drop it in your container.
So you've got to scoop up under the pit.
Or you could use a spoon.
Okay, so we're going to use our bare hands,
All right.
huh? Let's see if we can each get an antlion. You found your pit? All right, I think I'm going to do this pit and see if I get one. I got one. Did you get one? Not that time? For this experiment, we're going to need 30 antlions.
You have to be kidding me.
So we're going to catch the 30 antlions, and then we're going to meet you guys back in the lab to do the experiment. You ready to start digging?
Can't wait.
Okay, Ethan, so we've collected all 30 antlions.
Phew.
It was a lot of work. We have 10 in each container. And remember, our question is, how does the light affect the size of an antlion pit? Because the bigger their pit, the more they can trap ants, right? It's a bigger trap for ants. We have our antlion habitats. We've got 3 of them, and they all have the same amount of sand in them.
One's for no moon, one's for half, one's for
Full moon.
Full moon.
Correct. We have a light meter so that this will actually measure the amount of light when we get it all set up, and we know how much light is in each container, and this is going to show us our readout. Here is the light we're going to be using, and it's an aquarium light, and it has a spectrum similar to moonlight. It looks blue. So the full moon container will be left as is, and the light will go over it. The partial light is going to get this fabric put over it, because this fabric will let a little bit of light through. It's translucent, but not all of the light. And then behind you, I have a cardboard box, and that will go over the 3rd container, the container that we want no light in. Okay? So the first thing we need to do is rehome our antlions. So if we each take a container and we'll just kind of sprinkle them on top, they will begin to build their pits. We'll check on them every day for a week, okay?
Okay.
All right, go
That's
ahead. Go ahead and sprinkle them on top. Woo, there's some big ones and some little ones. and they are already starting to bury themselves. Now what we'll do is we'll give them a day to make their new pits, and then we'll start measuring their pits every day. But let's go ahead and set up their environment. Okay, so to measure the light, I'm going to put this sensor, this detects the light. I'm going to put it in the box with the ant lions, and then hit that green button that says start. All right, Ethan, so with the sensor in the box, how much light is it measuring?
0 lux.
Okay, 0 lux. So there is no light in that box. All right, Ethan, do you see the fabric behind you?
Yeah.
Grab the fabric and let's put it over this group. We're gonna put the fabric on, and let's go ahead and get our light on as well. Okay, and then let's turn the light on.
Whoa.
All right, and it's measuring
48.81 lux.
Okay, 48.81 lux in our second group of doodlebugs. Now we have the group getting the full light. All right, Ethan, how much is the full light group getting?
279.22 lux.
Okay, that's a lot more light, isn't it?
Yeah.
And every day of this week, we're gonna have to come check the doodlebug pits, and we're gonna measure them. Sound good?
Yeah.
All right, we'll see you soon.
Bye.
Okay, Ethan, so we're back in our dark laboratory under the stairs, and we've given our ant lions a day to start building pits. But remember, our question was, how does the amount of light affect the size of the pit? So, looking at the pits in here, how do you think you'd measure their size?
A ruler?
A ruler would be a good option. I'm going to show you a new tool that you've never used before. It's kind of like a ruler. See that? So these are called calipers. And they have a ruler, right? But then they also have these jaws. When I turn the dial, the jaws open. So when I open these jaws, I get a very, very precise measurement, and I can measure the width of the pit. Okay? Which pit do you want to measure?
This small one.
Okay, let's measure the width of this really small antlion pit. And it looks like this one is at 0.228. So that's 0.228 inches. It's a very small pit, isn't it? Here's what we're going to need to do now. We need to measure all of the pits. This is our full light group, but we also need to measure them for our partial light and our no light group. Okay?
Okay.
And then we'll have our data for today, but then we'll collect our data for 4 more days. All right? And we'll make sure everyone gets the data so that at the end of 5 days, we can look at our results and see if we can make some conclusions about how light affects the width of an antlion pit.
Okay.
All right? Let's take a look at our data. Now we've collected so much data that it's really important we put it in a graph. I'm going to show you 2 different graphs, and the first one you see on your screen is where we've plotted the data as points. So the bottom axis of the graph shows the days, and on the left-hand side we see the size of the antlion pits. Take a minute as a class to discuss this data. Where were some of the largest pits? How about the smallest pits? Do you see any trends or relationships? All right, now that you've had a chance to look at that graph, let's look at another type of graph. This is known as a box and whisker plot. You've probably never seen a graph like this, but for our antlion data, it gives us a pretty good picture. Again, the days are on the bottom of the graph. The pit size is on the left-hand side. But this time you see boxes. The boxes represent where most of the data is. So for example, that first blue box is the full light group. The whiskers just show the highest point and the lowest point, but most of the pits fit into the box. Do you see how the box is about the same size and in about the same place as the partial light and the no light box? What do you think that means? Take a minute and talk about this data with your class and decide whether this data supports your prediction or fails to support your prediction. All right, Ethan, our experiment's over. We made measurements for 5 days with full light, half light, and in the dark. And what did our results tell us?
Nothing.
Nothing, right? It didn't matter. The ant lions made big pits and little pits and medium pits, no matter how much light there was. Do you think that happens to scientists?
Yeah.
Sure. Sometimes scientists have predictions, and at the end of all their tests, they're not able to prove their predictions correct. And that's one of the reasons why scientists do so many investigations, because sometimes they get a lot more wrong than they get right. So we've come back from where we've collected them. Yeah. Should we return them back to their home? Yeah. All right, you want to do the honors and sprinkle the bucket and return these antlions back from where they came? Here, we'll do it together. I'll just put them here. There you go. And they'll make themselves home. There's one.
I see a quarter of the moon is gone.
It doesn't it?
Cool from here. It looks like a cloud.
It does kind of look like a cloud. Here we are in the daylight, and we can still see the moon.